We talked about SDLC, System Development Lifecycle. And in SDLC, you go through a number of steps in order to develop database applications. Right? And you start with the planning phase, and then you go to the next phase, which is analysis. Okay? And then you go into design. And in design, there are two types of design. One is the logical design, and the other is the physical design. And then you go into implementation, and then finally maintenance. So that's the SDLC process. And today we are going to talk about the analysis phase. During the analysis phase, the most important activity is called data modeling. And data modeling is probably the most important part of the database development process, because if you don't do a good job modeling the data in the analysis phase, then everything you do after that will be a waste of time. If you don't have a good data model to start with, then everything you design, everything you build would be useless. So data modeling is probably the most important task during the whole process. A number of things that you are going to model in this step. You're going to model entities. And entities are basically anything. It can be something that's physical, can also be something that's abstract, like a concept, an event, right? So anything you want to keep track of is an entity. So that's the first thing you want to model in the data model. And the second thing you want to model in the data model would be the relationship. The relationships between these entities. And then the third thing you want to model would be the business rules. Each business has its own business rules, so you want to specify these business rules in your data model. So those are the three things you want to model in your data model. And the tool that we are going to use for develop data models is something called entity relationship diagram, or we use the abbreviation ERD for the name of the tool, entity relationship diagram. Okay. And in order to draw entity relationship diagram, you can use a number of tools. You can use Microsoft Visio. That's a pretty good tool for drawing entity relationship diagrams. It has a tool inside the Visio for drawing ER diagrams. There are also other tools, a tool called ER Diagrammer. You can download it from the internet. Oracle has Oracle Designer, which can also be used to draw ER diagrams. For assignments, you can either draw it using Word or Visio, or if you want, you can also just use a pencil and a piece of paper and draw the ER diagram by hand. In this chapter, we're going to talk about the process of data modeling. We're going to talk about different elements of the data model, and also we're going to talk about some of the tools for drawing data models. I think in the book there is an appendix that talks about different tools for drawing ER diagrams. It will compare the notations for Visio with the notations from Oracle Designer, so that you can see different tools may show the ER diagram somewhat differently. So if you have some time, read that appendix at the end of the book. In this topic, we are going to talk about some of the terms, like what is an entity, what is a relationship, what is a business rule, and we're going to talk about the importance of data modeling, and we're going to talk about how to develop good names for data entities, attributes, right, and the data definitions, and so on. And we're going to talk about different types of relationships you will see in an ER diagram, and we'll talk about how to draw ER diagram for different business situations. And also, in particular, we are going to talk about how to develop the ER diagram for many-to-many relationships and associative entities, and also how to model the time-dependent data using timestamps. Because these are very common situations you will run into in a business setting. You will run into a situation in which there are multiple entities will have many-to-many relationships with each other, and also you will run into situations in which data is time-dependent, which means they will change as time changes. So those are the topics that will be covered in this particular chapter. First of all, let's talk about business rules. Business rules are not universal. Each organization has its own business rules. So it's very important for a database designer or system analyst to draw these business rules in these technical diagrams so that programmers can program these business rules in the application. And sometimes these business rules can also be programmed in the database so that the business rules can be enforced by the database management system. What is a business rule? Well, a business rule can be a number of things. First, it can be statements that define or constrain some aspects of the business. For example, if you define what is a student or what is a customer, the definition for the entity student or definition for entity customer, that's an example of a business rule. You may say that a student is somebody who has registered and who may have taken classes or may not have taken any classes. That's an example of a business rule. It's a definition of a data entity. A business rule can also assert business structure. It can be describing a particular business structure. For example, each department has a department head, and all the purchasing orders must be authorized by the department head. So that's asserting a business structure. Or a business rule can be something that will control or influence business behavior. For example, a business rule can be, well, for all the preferred customers, we give them a 10% discount on their purchase. Each order must be assigned an order number. So those are all examples of business rules. Like a business rule must be expressed in terms familiar to the end users, and end users are usually referring to business managers or business users. Business rule must be stated in the business terms rather than technical terms. And usually these business rules are programmed in the application or in the database so that they can be automated through database management software or the application. So as a database analyst or a database administrator, you would do three things. First of all, you need to identify these business rules. So how do you identify these business rules? Well, usually you identify these business rules during interviews with users or by reading the documentations for business, like manuals or procedures and so on. And then the second thing you need to do is you need to represent these business rules in your data model. Find a way to represent these business rules in the data model. And sometimes it's represented in the relationships, and sometimes it needs to be stated explicitly as a business rule in these data models. And then the third thing you need to do as a database analyst is to implement these business rules in the database, which means you need to program these business rules in the database. During the data modeling process, all you need to do is to identify the business rules and also represent them in the data model. You do not implement these business rules during the data modeling process. So once you identify these business rules, you need to somehow state these business rules. So what are some of the guidelines for stating business rules? Well, here we have a number of guidelines. First of all, a business rule needs to be declarative, which means it will declare what this business rule is, but it's not going to tell you how to enforce this business rule. So for example, if the business rule is that all purchasing orders must be authorized by the department head. So it tells you what the business rule is, right? But it doesn't tell you how the department head is going to authorize the purchasing order. So it tells you what, but it doesn't tell you how to enforce the business rule. And the second guideline here is that business rule must be very precise, must have a clear, agreed upon meaning, which means, well, there can only be one interpretation for the business rules. They have to be atomic, so it only includes one rule rather than many different rules. So for example, if you have a business rule that says all purchasing orders must be authorized by the department head who is elected by the department members, well, then that's not an atomic business rule because it has actually two business rules. One is the purchasing order must be authorized by the department head. The other rule is the department head is elected by the department members. So you have to make sure that there is only one rule in each business rule. They have to be consistent both internally within the organization and externally, which means it has to be consistent with other business rules. They have to be consistent with the law, right? And they must be expressible. They have to be stated in natural language so that people can understand it. They have to be distinct, non-redundant. You cannot have repetitive business rules. And they have to be business-oriented so that they can be understood by business people. They are not stated in technical terms. One important decision you need to make during the data modeling process is that you need to name all the entities, relationships, and sometimes even the business rules. So how do you come up with these data names? Well, there are also some guidelines for coming up with good data names. For example, here on this slide we have a number of guidelines here. The data name must be related to business, not technical characteristics. For example, if your data name is file 0012, well, that's not a very good data name, right? Because it doesn't make any sense to the business people. This is a technical name that's referring to a file number. Or if your data name is customer primary key, that's not a very good data name either, right? Because most people don't understand what primary key is. So you need to make sure that the data name is business related, not a technical name. They have to be meaningful and self-documenting. They have to be somewhat self-explanatory. Data names need to be descriptive. Cannot use something that's too abstract. For example, like person, that would not be a good data name because it's too abstract. Or thing, right? Or stuff. Right? These are not very good data names because they are not very precise. They have to be unique. Within the same table, you cannot have two attributes or fields that have the same name. And within a database, you cannot have two tables that have the same name. And within the whole organization, you cannot have two databases with the same name. They have to be readable. And also, usually, these data names used in a company's database are composed of words from an approved list. And this approved list is usually approved by the data administrator who sets the policies for databases, or it can be approved by a group of users who are involved in the database development process. It needs to be repeatable, which means there should be a pattern that you can follow, and also it should follow a standard syntax. For example, if the syntax is that you will capitalize the first character in the business name, like customer, like capitalize C, and if the syntax states that if there are two words, then you need to link them with a underscore. Say, for example, customer name, so you will say customer underscore name. In the future, when people create data names, they know there is a syntax to follow. In ER diagrams, there are a few things you need to model. First, entities. Within entities, there are two concepts. One is called entity instance. The other is called entity type. An entity instance is referring to one person, one place, one object, one event, or one concept. So it's an instance of the entity type. An entity type is the collection of these entity instances. So for example, John Smith would be an entity instance of customer or an entity instance of student, but customer would be the entity type which contains John Smith. So that's the difference between entity instance and entity type. And anything can be an entity. For example, student, customers, these are people, building, college, university, these are all examples of entities. And then the other thing you want to model in ER diagrams is the relationship. Again, there are two concepts here. One is relationship instance and the other is relationship type. One link between the entities. For example, John Smith places order. That's a relationship instance. It's because it's an instance of the relationship type. And the relationship type would be places. Another thing you want to model in ER diagram would be the attribute. And attributes are the properties or characteristics of an entity or relationship type. For example, let's say the entity type is customer. But there are a number of characteristics or properties of the customer. For example, each customer will have a customer ID. The customer ID is an attribute. And each customer has a last name, right? So that last name is an attribute. First name, that's another attribute. Sometimes the relationship type will also have attributes associated with it. For example, let's say one entity is product and the other entity will be order. And between order and the product, there is a many-to-many relationship because one product can appear in multiple orders and one order can have multiple products in it. And for this relationship, there can be an attribute associated with it, which is quantity, which specifies the quantity of the product in a particular order. So the attribute can be describing an entity or it can be describing a relationship. Let's take a look at this ER diagram here. Obviously, it doesn't have all the elements that ER diagram has, but it has some of the most important elements here. What we have here is an ER diagram that has entity types and the relationship types, as well as cardinalities. The crow's foot or the bar here, or the circle here, these are called the cardinalities. So let's take a look at this ER diagram and see how we can interpret it. Okay, let's start from the customer entity type. So the customer entity type submits order. And between the customer and order, there is a one-to-many relationship because customer can place multiple orders and the one order can only belong to one customer. So that's how we read it. And then order and the product, between these two entities types, there is a many-to-many relationship. The order requests product. And then between product and item, again, there is a many-to-many relationship because one product can use multiple items in making the product, and one item can be used in multiple products. And then, well, the item is supplied by suppliers. And there again is a many-to-many relationship between supplier and item because one item can be supplied by many different suppliers and one supplier can supply many different items. And then the item is included in shipments. Again, many-to-many relationship, and the supplier will send out shipment, and it's a one-to-many relationship between supplier and the shipment. Right? So this is how you read an ER diagram. And as you can see, those rectangular shapes, they are referring to entity type. And then the relationships are represented with a line here. And then there are a number of different types of cardinalities you will see. The first one that has two bars, that's called the mandatory one. The thing about cardinality is there are two types of cardinalities. One is called the minimum cardinality. The other one is called the maximum cardinality. For mandatory one, both the minimum cardinality and the maximum cardinality are 1. And for an optional many, the minimum cardinality is 0, and the maximum cardinality is many. Okay, so what does this mean? Well, let's use one of these as an example. Let's use order and the product as the example here. All right, so between order and the product, it's many-to-many relationship. On the order side, what we have is the optional many. And on the product side, we have mandatory many. So what it means is, well, for one order, the minimum number of product it will request will be 1. Because if there is an order, there has to be a product in it. So that's why the minimum cardinality here is 1. And then also for one order, the maximum number of products it can request would be many, any number. So that's why the maximum cardinality here is many. And then for one product, okay, the minimum number of order that request the product can be 0 because the product may not appear in any orders. So that's why the minimum cardinality is 0. And the one product, if it's popular, it may appear in many orders. So the maximum cardinality is many. So that's how you read the cardinalities. So as you can see, in this simple ER diagram here, it shows the entity types, right? It shows the relationships, and also it displays the business rules through these cardinalities.